whatever the tea that is given to her, she will say this tea was prepared by using this method, or this tea was prepared by this particular method. So this is called a lady tea testing problem. So this problem is containing the planning of the experiment and also the properties of the experiment and the hypothesis and uncertainty principle and the concept of the probability and the testing process, and also it is involved the principles of the experimental design. So this is the total organization for design and analysis of experiments. Okay, so that's why this problem is one of the most important problem, and which is a real and which is very easy to understand because I'm going in a non-mathematical approach. Now, how could one design an experiment to assess her claim that whether she is having such a discriminating power or not by testing the T? So here our the major problem is state the problem, statement of the problem that you have to specify. So this is nothing but what is the hypothesis to be tested? What what is her claim? Whether she is having a discriminating power or not. So I am taking one statement that H naught. The lady is having a discriminating power. That is called a null hypothesis. Alternative hypothesis. She is not having a discriminating power. So that is the alternative hypothesis. The next statement, determine a treatment design. So for testing that particular hypothesis, what are the treatments? So that means what type of the uh, whatever the experiment that you are going to define for the combination to be tested. So those that you have to define it here. So what treatments would be considered to be tested? So that means indirectly that I'm converting the hypothesis into a treatments. And the next step is determine an error control design. What are the errors in conducting the experiment and how to rectify those such that she is not in a position to discriminate the T. So I'm preparing such that 90% I'm totally, she should not in a position to discriminate such that I'm conducting it. But the hypothesis that I'm null hypothesis that what I'm taking is she is having a discriminating power. Alternative hypothesis not having a discriminating power. Okay. So null hypothesis that what I defined, that is the possible rejection of a true statement. So why about which statement that you are more favorable, that statement only that you take and you try to reject so that I'm planning for the experiment. So what are the sources for the error? So here I am giving in the method itself. So what are the sources of the errors and how to fulfilling or rectifying those errors, and determining a sampling and observation design. How will data be obtained for the analysis and connect the design to a statistical method. So these are the major, the five important, the point that you can examine in designing of the experiment, that what I in given in the previous planning of the experiment. Now coming to the statement of the problem itself. So one approach in the experiment that what I am planning, one approach of the lady is not able to discriminate between the cups of tea and milk made tea first and tea after. So that means here I am taking in the initial stage only, whatever the tea, that means tea, what infusion, and that is a tea powder, water, milk, sugar, all are added at initial stage only and boiled and making the tea. And in the another stage, another method, so whatever the first the milk is water is boiled, and next that I'm adding the tea powder, and so once it is boiled, the later that I'm adding the whatever the sugar quantity that I'm adding it, and the next that I'm adding the milk
adding the
and boiled. So these are
milk.
the two methods that
Adding the
I'm boiled using.
so these are the two methods that
And
adding the
I'm
and
I want to
so these are the two methods that
and
adding the and
test
I
using
want to so these are the two
whether
methods that
and
adding the
method one or
and boil.
test
I
using
want to so
milk.
these are the two
So
methods
by
that
tasting
adding
the
the
tea,
and boil. I
whether
want
she
to
is
so
happy
these
to
are the
drink.
two
So
methods
by
that
tasting
adding
the
the
tea,
and
now
boil. Whether
I'm
she
making the
happy to drink.
precautions
So by
because
tasting the tea
suppose
and
when you
boil.
are adding
I'm
the
making the
milk in the
precautions
later, it should not
because
be seems to
suppose
be
now
the color
I'm
should not
making
be
the precautions
changed.
because
So whatever the
suppose
be
now
the color
I'm
this
making the
one change, the
precautions
color must be
because
same.
whatever the be the color this one change,
And
the color must be
whatever
same.
the
Whatever the be
sugar
the color
quantity that
this
is
one
added,
change, the color must be
whatever
the
the first method or
sugar
second method
quantity that is
must
added,
be
the color
the
whatever
sugar
the
level
first
must
method
be
or
same.
second method must be
And
the
the
sugar level must
tea
be the same.
powder that is added is also
And
must be
the sugar
same.
level must be the same. Powder that is added
So and
and
also
the
that I am
tea
taking
powder
another
that is added
precaution set
and
here.
also that I
I
am
am
taking
taking the
another that is added
in a
precaution
tray
set here.
totally
I am
8
taking the
similar
another
cups.
that is
In a
precaution
tray,
set here.
the
Totally 8
cups
similar cups
seems
in
to
a
be
tray.
same,
Totally 8
and
similar cups seems to
it
be
is
same. Totally
two
8
methods of the
similar
tea that I am taking
it is
in 4 cups
two methods of
and
the
totally
tea
8
that I
cups
am
that I am
taking
taking it.
in 4
Out
cups.
of the 8
Methods of
cups,
the totally 8
in
cups
4
that I am
cups,
taking it.
the
In
method
4 cups of the
1
8
tea that
cups,
is
totally 8 cups
4
I am
cups,
taking it. The
and
method
another 4
1
cups
is totally 8 4
the
cups.
whatever
And
the method
another 4
2
cups is totally 8
the
4
tea
cups.
that is
Whatever
prepared
the method
that is
another
4,
4 cups is totally 8
and
4 cups.
the level
Prepared that is 4
in the teacups
and
is also
the
must be the
level
same.
whatever the method is the
And whatever
teacup
the
is also must be the same.
temperature is also must be
And
the
whatever
same.
the
So
temperature
temperature,
is also must
the
be the
color
same.
of the tea,
So
sugar level,
temperature
or tea
the
powder
color of the
that
tea,
is
sugar
the
level or tea
quantity,
powder color of
and
the tea,
so these
sugar
are all
level
cups.
or tea powder
So
and
all are
that
seems
is
to be
these are
we
all
are not in a
cups
position
quantity.
to
So
distinguish
all are seems to
directly.
be
It is
we are not in a
totally
position
must be
to
in a
distinguish directly.
confusion time.
We are
Just
totally
some
must be in
uncertainty you have
a
to
confusion
maintain in this
time.
part.
Just some
So
uncertainty
if you
you have
are
to maintain in this
preparing
part.
the tea
Just some
like
uncertainty you
the
are
for one method
preparing the
that
tea
it
like
seems to be
so if you
totally
are
the red
for one
and
method
milk is
the
added
tea
very less,
it
and
seems to be totally the
milk
red
is
and
added
milk
more
is added
quantity,
very
it is
less
very easy
and
to add.
totally the red
Milk is
and
added
milk
more
is
so
added very
here
less
I'm taking more
and
precautions about
totally the milk is
the
added more
preparation of the
so
tea or
here I'm taking
these
more
two
precautions
methods.
about the preparation of the
So
tea
then
or
only we
taking
can
these two
test
precautions
whether
about
that lady is
the preparation
having
of the tea. So then
an
only we can
exact
test whether that lady is having. So
discriminating
then
power
only we can
or not.
test whether that lady is
So
having. So then only we can
hypothesis
test
the
whether
is
that
whether the
lady is
lady is
having.
having
So
a discriminating
hypothesis
power or not.
is whether the
So
lady is
what are
having
the
a discriminating power or not.
measurement that I am
So what
taking
are the
or what are the
discriminating
calculations
power
are
or not.
involved
Measurement that I am
in
taking.
this
So
part
what are
that
the
I am
calculations
exploring
are
it now.
involved. Measurement that I am in this
The
part
sources of
that I am
error or
exploring it
even
now.
the lady is able
The
to
sources of
discriminate as
error or
she
even
says
the lady
she
is able
may
to
make a
discriminate as
mistake
or even
from time
says
to
the
time.
lady is able to make a mistake
This suggests
from
that
time to time. Lady is able
we
to
should
make a
present
mistake. This
her
suggests that
with several cups
we
of
should
tea
present
with
this
milk.
suggests that with several
So
cups of tea
we are saying
this
that means some
suggests that
8
with
cups.
several cups of tea
Different
we are saying that
materials
means some
may
8
interact
cups.
with the flavor of the
Different
drink
materials
in
may
different
interact with
ways.
the
We should
flavor of the
use
different materials
the
may
same
interact
type
with
of cup
the flavor
for
of the
each
different
drink
materials the
in each
same type of
treatment.
cup we should for each drink
Note
in the
that
same type
this
of
means
cup
for instance, if for all four T, 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 for instance, if for all
Hello, sir. Any issue? Hello, sir. Any issue? Hello, sir. Any issue? Hello, sir. Any issue? You were not in the first. You were not in the first. You were not in the first. You were not in the first.
Hello?
Sir.
Actually, power is off.
Sir.
So due to that, actually power is off.
It's okay, sir. It's okay.
Yeah, the hotspot that I have opened,
It's
but
okay, sir.
there
It's
is
okay.
no hotspot that I have opened. So
It's
now
okay,
the
sir.
screen is it sharing? Okay. So now the screen is it sharing?
Just a second, sir. I will give you.
So now the screen is it sharing?
Just a second, sir. I will give you.
So now the screen is it sharing?
Just a second, sir. I will give you. Okay, sir. We can see your slides. Okay, sir.
Okay.
We can see your slides. Yes, sir.
Okay, right.
sir.
Okay.
We can see your slides.
Okay, thank you.
Yes, sir.
Okay, sorry for disturbance. Okay, thank you.
Yes, sir.
Because due to sorry for electricity is okay, thank you. Because due to sorry for
No
electricity is
problem.
okay, thank you. Because due to sorry for
No
electricity is
problem.
okay, thank you. Because here out of these eight cups that the four cups are one method and the another four cups are another method. So these eight cups are also arranged in that tray in a random order, and we are requesting that lady to taste each cup and lady to say whether it is prepared by the method one or method two. Whether it is prepared now. She is also having free to access any of the cup. She is also having free to and access any of the cup. Also that and first cup too, there is some problems are there in this one. There is some when you are tasting the first cup to the last cup. When you are there some first cup temperature may be decreased. So due to that, that which is not in our hand. So first cup, so second cup. So I am giving totally four chances only to that second cup, not the eight chances. Now I am evaluating eight chances. Now the what are the possibilities are there? Now the so I am calculating the probabilities that are involved in this one. I am calculating the probabilities that are involved in this one. I am calculating the probabilities that are whatever the possibilities that I am calculating, whatever the possibilities that I am calculating, all the four chances that whatever that are given, all are that whatever that are given. So this is one possibility. Or only one correct. One correct means so either it may be one correct. One correct means first cup. So either it may be second cup, or first cup, third cup, second cup, fourth cup, or first cup. Third is the first chance. First cup, whatever she has taken, this is correct. First cup, whatever the second cup she has given correct answer is chance wrong, and second chance, third chance, fourth chance correct, like that. And in all the chances, four that she has taken, all are correct. So none is wrong in this case. Now, what are the possibilities that are involved in this case? Now, the same thing here. So the correct answer, zero correct, one correct, two correct, three correct, four correct. That means how many wrong? So zero correct means all are wrong. And one correct means three are wrong. Two correct means two wrong. Because I am giving the four chances to her. So out of the four chances, so zero correct, four wrong. One correct, three wrong. Two correct, two wrong. Three correct, one wrong. And four are correct, none is correct, one wrong. So what are the possibilities for this? Because I am giving the totally in the tray, totally 8 cups are there, and the four giving to that lady only. I am saying that out of this 8 cups, in 4 cups, method 1 tea was presented, and in another 4 cups, the second method tea was presented. So out of this four, none is correct. The chances are 4C0. That is, this is a permutations and combination that I am using it. 4C0 means permutations and combination that I am using it. And 4C0 means 4C4. All correct, all are wrong. 4C4. All correct. This 4 is for this one. Okay. This is also one possibility. So 1 into 1. So that is one possibility. And one correct, three wrong. Out of the four, only one correct. There are four possibilities are there. 4C one value is 4. And even 4C3 value is also 4. So 4 into 4, that is, there are 16 possibilities are there. For giving the answer, only one correct and three wrong. And two correct, two wrong. There are 4C correct, two wrong. So 4C2 means 6. There are 6 possibilities are there. And there are another 6 possibilities. There are 6 possibilities for wrong also. So 6 into 6, because all are simultaneous. Therefore, the 36 possibilities that are existing. So 3 correct, 1 wrong. So the possibilities are 4C3 and 4C1. So therefore, totally there are 16 possibilities that are existing. And all are correct, none is wrong. There are 4C4 into 4C0, the resulting value is 1. So there is one possibility. So totally, out of this, when we are giving the 8 cups, why I am giving the 8 cups? Is if I am giving the 8 cups and saying 4 cups are one method and 4 cups are another method, and giving the 4 chances to her, then it is totally there are 70 possibilities are there. Out of those 70 possibilities, the first possibility all are wrong. The probability for giving all wrong, the probability is 0.014, very less than 1%. Very less, okay, less than 1%. One correct, 3 wrong answers. So the probability is 0.022. So one correct answer for giving, the probability is more at here. 0.2. The probability is more at here. Almost 22%. Almost 2%. The probability is 50%. 2 correct and 2 wrong. 50%. And 3 correct is 1 wrong. The probability is 3 correct, 0.2 wrong. Around 22%. 22.8%. Around 22%. Again, 4 correct and 0 wrong. Again, the probability is 0.014, which is also very less. Now, out of this, which is also very cannot use for which we cannot use for having a discriminating power. Therefore, the first possibility, this is totally ruled out. So even the probability is very less. Now the second probability, so one correct, the probability is 22%. I had already given what is the type 1 error and type 2 error. Type 1 error, the probability for or the chance the rejecting when H naught is true. That is called type 1 error. The probability for type 1 error is called the level of significance. So that means the statement is correct. What is the probability for it is rejecting? So that probability is here is more. So therefore you cannot claim it. So based upon one correct claim it. So when two correct answers, this is 50-50 chances are there almost 50%. So 50% chance only, then how we can say that she is having a discriminating power? So it is ruled out. Now three correct answers, the probability is 22%. Still, it is more than the type 1 error. Therefore, you cannot say. Type 1 error, what is the maximum allowable error? Only you are taking 1% or 2% or maximum 5%. 5% error that you are allowing. More than 5%, 5% error that you are not allowing. More than 5%. So maybe that is due to some error or randomness that may occur. So therefore, we are considering only up to 5%. Now, this probability is 0.014, which is almost less than 5%. So it is in between 1% to 2%. 1.1%. This is actually. So somewhat that you can use. This is actually. So the probability that you are how you are getting, because if the more possibilities are there, how you are getting more possibilities by giving more number of cups and more number of chances. So you are giving the totally 8 cups and 4 chances that you are giving, and based upon that only you are calculating the probability here. So whenever you are conducting the experiment must be repeated. More chances that you are giving means the more the number of times the experiment must be repeated. By suppose if only one chance you are giving, by luckily she has given a correct answer, then if I am saying that she is having a discriminating power, it may not be possible in all the cases. Therefore, you cannot use it all. I am giving only one cup of tea and taste it and set correct answer. Then based upon that you cannot say that she is having a discriminating power. Suppose if I am giving only second cup, suppose if I am giving only 50-50 chances that you will get. First cup 50 correct, second cup is also correct. Then we cannot say that the probability is more than the allowable error. Therefore, I am not using only the allowable error. That's why here I am taking the more number of chances. So that's why whenever you are conducting the experiment must be repeated more number of times. Not repeated one time or two times or three times. So minimum 4 times that you have to repeat it. So that's why generally whenever you are collecting the experiment observations, you are taking more number of observations. Minimum 4. Okay. So why? What is the cause for this that you can examine? So why this particular cause for this that you can examine? This type of the repetition, repeating the experiment is nothing but replication is nothing but the principle of replication. Repetition of the experiment. The principle of replication. Repetition of the experiment. The principle of replication. Repetition of the experiment. So from this particular experiment that I am evolving these three principles: randomization, replication, and randomization, replication. And now what is the randomization? So randomization, how is the principle that not randomly adding sugar or not randomly adding the tea powder or randomly adding the milk like that. Because if you are randomly adding maybe less or more, then it is very easily to identify. So the randomization where that you have to apply, when where that you have to apply, that is also the most important part. Okay, so I'm arranging the cups in a random order. Because cups are seems to be same, color is seems to be same, temperature is seems to be same, sugar level is seems to be same. Therefore, you can arrange these cups in a random order and takes the chances free or to take one of the cup randomly. Only four and four that you take and taste it, it is also not correct. So randomization is also not, because only out of the eight, four means the randomization is somewhat possible. Only one cup is given and taken, then where is the concept of the randomness? There is no randomness. You are giving a child no chances to her. And the replication principle is repetition. So we are repeating the four chances or five chances or six chances and collecting the more number of observations. So due to the replication principle, suppose we are conducting the experiment. Experiment is conducted first time. I am collecting the reading. This is a one pilot survey time. And second time, because we are not familiar with some methodology and not familiar with the conducting of the experiment, or not familiar with the set of rules, or due to that, there is some the mistakes there is a chance to commit. Therefore, you have to get more familiar with the conducting of the experiment. So, first time there may be some error, maybe more errors will be lower. Therefore, whatever the observation, you cannot directly consider it. Second time, somewhat you are familiar with the procedure or the experimental, the methodology, and you are making some more precautions and you are getting some more experience, somewhat experience. So whatever the errors that you have committed in the previous, you are having a chance to rectify those in this one. Again the third time, you are more familiar. Again the third time with conducting of the experiment, and whatever the precautions that you are taking is also more, because first time, because due to lack of experience, so you are conducting some errors may be rectified in the second, but some more are not taken some precautions, so that is also maybe rectified. So if you are repeating the experiment the more number of times, then the observations or results are also will be more accurate, which are mainly used for the analysis. The true analysis will be coming from that particular point. So the experiment must be repeated. So that suppose you are tossing the coin. When you are tossing the coin, you are saying that 50 chances, 50 percent chance is there for head appearing and 50% chance for tail appearing. Suppose if you are tossed the first time or two times, is it exactly one time head and one time tail? No, because you may not be familiar with tossing of the coin, how it is moving freely, whether you are in a position to guessing or not. So you toss the coin more number of times, and what are the major precautions, where you have to toss, under what condition that you have to toss, is also the most important point. So this is also involved. So some uncertainty may be involved, but the systematic conducting, the rules that you have to follow is also most important for conducting of any of the experiments. And here error comes. So error is controlled by repeating the experiment and also by using the randomization. And whatever the experimental conditions, we are controlling the errors, just like whatever the sugar level is added is cups are seems to be same. Suppose if your first method is first one type of the cups, and second method is given another different type of the cups, then you are automatically discriminating. It is no need to give it to her to discriminate. So that type of the errors that you should not control. So some errors that you have to control, some errors which we cannot control it. Those errors are even that you are the similar condition that you are conducting, the temperature is same, and whatever the sugar pill that is added, maybe one or two, maybe more or less, because due to boil, the temperature initially that is seems to be same, but there is some changes are that you can examine, which are very minute. So based upon this minute only, she is having a discriminating power. So the experiment conducting itself is containing some error control, and error control is mainly based upon the principle of the replication, and homogeneity is to be maintained. That is major is error control, and some errors which are random. So totally the errors that you are classifying into two types. One are called the chance errors and assignable errors. The chance errors are which are totally random, not in our control, and the assignable errors which we cannot control, which are beyond the human control. So those errors are called random errors. Assignable errors are which are in control of the human. So those that you are controlling. Okay. So these are the major three principles. So whatever the experiment that you are conducting, and when you want to test it, so these three principles must be involved. So without involving of these three principles, if you are testing the hypothesis, it is not a suitable experiment. Okay. And what are the advantages and of each one of the randomization or replication and local control? Randomization is the allocation of the experimental material is at random, and the order in which the individual trials of the experiment performed is at random. This random is said to be the principle of randomization. It helps independence of the observations. It helps how the observations are independent. That is making it here. Whatever the assumption, which is the most important for the applying of the statistical tools, and the concept of the probability that is involved is also based upon the randomization, which is necessary for drawing the valid inferences from the observation. And the errors we are saying that they are random. So due to the randomization only, the errors are random, and they are independent and identically distributed. And we have an objective comparison among the treatments. So the randomization due to this, whatever the our objective is there to compare whether all the treatments providing the provides the estimate for error variance, and it is a function of the difference among the observations from the experimental units under identical treatments. And whatever the third principle is error control, the measures and methods used for reducing the error in conducting the experiments which are under the control of the experimenter, which is generally said to be an error control. The error control can be measured by using the general formula, the square root of s square variance. S square is called the sample variance by r. R is nothing but the number of times the experiment repeated or number of observations type. Okay, x square by r. So r is generally called replication. Suppose I am having 10 observations. So suppose whatever the variance is there. So this 10 observation variance we are supposing there be some 100. And then we can say that square root of and then 100 by 10. Because 10 observations variance is 100. I am saying now the advantage now of this error control is make the experimental units are homogeneous as it is possible. Because if the experiment whenever you are conducting under similar conditions, homogeneous conditions, then automatically the error will be controlled and make more number of repetitions. Because when the experiment is repeated, automatically by getting more experience, then error will be controlled and standardization will be maintained in that by using this frequent approach, and skilled and experienced experimenters, and we have to use the whenever we are conducting the experiment, the skilled persons and who is having more experience, those only they are maintaining this part, and so those who are having a lack of experience, so those should not be placed in the initial, and in that type of the cases, those observations you have to eliminate for the analysis. The methods for the user must be systematic. So whatever the methods must be accurate methods only, and must be very systematically that you have to use it. So these are the major advantages for these principles of experimental designs. Okay. So now, okay, the experimental error, the variability in the characteristic of the biological materials. The total variability can be partitioned into explained and unexplained parts. So the observations in the experimental unit differ because they belong to explained and unexplained effects. The experimental error is of two types: systematic and random. So like assignable and chances. And systematic errors change the measurements in a consistent way and comes from different source, and that is in conducting of the uniformity in the units, such as uncalibrated instruments and all those. And now, whenever we are conducting any of the experiment, here we are mainly using some of the basic terminology. Some of the basic, those are experimental unit, sample, replication. Experimental unit is the material to which the treatment is applied. Either maybe in the agricultural experiments, so crop of flowers, so whatever the cattle, whatever the experiment that I am using it, experimental material. So we are dividing the total experimental material into parts generally sent to the experimental units. So that is about which treatment. So that is about the how we are applying that is also the most important part here. The characteristic of the experimental unit is that they are independent of one another. The sample may be a part of the experimental unit. The number of chicken in a cage denotes the chicken as a sample and cage as unit. Again, the experiment of weight gain in cows. So cough is both experimental unit as well as a sample. So it depends upon the experiments, it may be changing it. The replication is the application of the treatment to more than one experimental unit in any of the experiments. The random error occur due to the random and unpredictable phenomena. They produce variability which cannot be explained. In biological material, there are always random errors in measurements. And random errors can be minimized by increasing the number of replicates. Now, coming to the exact design of experiments. So here I am using various experimental designs and that classification also that I will going to specify. So major designs, that basic designs are three. Completely randomized design, randomizer block design, and lattice square design, and some other designs which are factorial designs, and there are some other the modeling designs which are response surface designs and mixer experiments, and also that are already given some of the post hoc tests like least significant desert and Duncan's multiple range test and surface t test, Tukey's t test, etc. These are some post hoc tests that you are applying in any of the analysis of various techniques that you are applying it. And all these designs are completely randomized design or randomized block design or lattice square or factorial or response surfaces or mixer experiments or many other designs are there like incomplete block designs, balanced incomplete block designs or Taguchi design which is also the part of the some incomplete block designs and also we can apply with response surface design modeling like that and partially balanced incomplete block designs, Euler square designs, so that we are having many of the design of experiments. Now I am giving some type of the experimental designs, various types, various experimental designs, varietal experimental designs. Varietal means we are testing the treatments directly. So these are major, complete and incomplete block designs. Like completely randomized design, randomized block design, lateral square design, balanced incomplete block design, partially balanced incomplete block design, Euler square design. These are all generally said to be varietal experimental designs. So first three like completely randomized lattice square. These are called completely block designs. And incomplete block designs are balanced incomplete block design, partially balanced incomplete block design, Euler square design, and some symmetric designs. So like that, those are triangular design. Those are row column design. All are incomplete block designs. So those are all varietal experimental designs. Directly you are testing the treatments. And these are another type of the experimental designs they are existing. Those are called factorial experimental designs. So the treatments are individually that you are applying that thing. So whereas at here in this one we are not applying individually as a combination that you are applying. That is the major difference between the varietal experimental to the factorial experiment. Let's suppose I want to study the effect of nitrogen, phosphorus, and calcium and zinc on a one particular agricultural crop. So I'm taking some small across of land and so I'm applying randomly zinc that I'm applying on that particular crop and another land that I'm applying the phosphorus, another calcium that I'm applying or like that. I'm collecting the heats and I'm studying the effect. So those are all the varietal experiments. Suppose if it is the factorial experiment, I am not applying the zinc and calcium and these are individually. I am applying as a combination. Low dosage of zinc and added high dosage of phosphorus or medium of phosphorus and another is also medium or low level, all other is high level that I am applying. So like that as a combination that I am applying to each crop. And but I want to study on the effect of the individual treatments. I am not applying zinc, phosphorus, calcium independently, but combination that I am applying. But I want to study the effect of the zinc or this one as individual. So in that type of the cases, the factorial experiments are and because there is an interaction effect is involved in the concept of the factorial experiments. So in the factorial experiments also there are many different type of the symmetrical factorial, asymmetrical factorial, with confounding, without confounding, fractional factorial. So those are all existing in the factorial experiments. And another are response surface designs. Like rotatable designs, central composite designs, and Taguchi designs. So those are all we are having a first order response surface design. So one polynomial equation that is existing at here may not be in a linear, maybe a second order, third order, may not be fourth order. A polynomial second order, the statistical model that we are going to use. Whereas in the varietal experiment and whereas factorial experiment we are using only the linear statistical model. But whereas in the response surface, the polynomial equations are applicable. Just like it is almost a regression model. And another type are mixture experimental designs. Mixture experimental designs are also the combination that I am applying, just like it is in how you are applying in the factorial experiment. Let's suppose a gold is item prepared with some percentage of copper and some percentage of gold. So for every 10 grams gold, 1 gram that is added. So to make, and I want to study the strength. So the copper is added more, then study the strength will be more. Suppose if it is pure gold, it is not that much of strongness. So mixing of the items. So in that type of the cases, so mixing of the items you want to analyze. So in that type going for the mixture experiments. And in the mixture experiments also, there is some possibility for first order models and second order model and third order model and so on. So polynomial equations that are third order model and so on. And there are some other type of the designs called the repeated measurement designs and crossover designs, which are mostly that are applicable, and row column designs that are applicable, the biological assays and row column designs and diallel crosses. So biological crosses, bioassays, these are all mostly we are going to use in the pharmaceutical industry, much more clinical trials, and whenever the probit analysis and logic analysis, whenever those are mostly that are applicable for analyzing such type of the applicable. For analyzing, these are the various other specifying ones that are present, zeros those are not present, right? Suppose x is equal to this matrix that you will replace, and beta is equal to mu alpha 1 alpha 2 so on alpha k. Mu corresponding is 1, always present. Alpha 1 is 1, so first one y11 mu plus alpha 1 plus epsilon 1 1, so that experimental homogeneous only that you have to consider in this one. That is a major restriction. Replication is there. We are repeating the experiment. So the same that you are applying for many of the patients. And the third one, the local control. Error principle is fully applied because the experimental material is totally is homogeneous. All similar type of the patients, not having any other type of the diseases. And we are not having the either sugar patients or BP patients or any other problem patients. Just to only affected to the COVID. Or suppose I'm not studying, they are having some problem of the respiration problem in the previous time. So this type, this is a completely randomized. It may be applicable in all the cases or not applicable. So what are the conditions that you have to check it once? Now I'm going for the another type, second type. Now how to carry out the analysis for the completely randomized design? So just like we are carrying out the analysis of variance one-way classification for this one. Okay, the same procedure at here. Now, an experiment was carried out to determine the effect of the claying. So here, four that are taken and A, B, C, D. These are the four treatments that you assume it. Stands for no clay, and B stands for clay at 100 per acre, and C for clay at 200 per acre, and D stands for clay at 300 per acre. Now we are conducting the experiment on some particular land area and collected the yields, and these are the D's applied at different places. I got 29.1, 21.2 are the yields that are collected. Now I want to carry out the analysis. So whatever this is the general procedure and you complete it. Okay. So just to carry out the analysis of various one-way classification. Now the another design is a randomized block design. Uh, in the randomized block design, the experimental material is not totally is homogeneous. So there are some differences are there. I'm not finding the experimental material at one place. Now suppose I want to apply the effect of the nitrogen and phosphorus and calcium on a paddy crop, but the soil I'm finding at one place red soil area and another the black soil area. So two that I had considered it, or so three types or three different districts that I found it. I'm studying the effect of the same because the environmental effects may be differ, so may not be the same. So due to that, the experimental material is not homogeneous. Even the patients. So some are the BP patients is one group, COVID, and the sugar patients of the COVID another group, and those who are having facing the problem of respiration is another group, and no problem, no complications. So with those are another group. Now I'm vaccinating this COVID. So then we can study the effects. So already the experimental material is not homogeneous. That means what our experimental units are not homogeneous individuals. So different groups. So this whenever you are dividing that into different groups, these are called blocking. This is one of the major concepts. Completely randomized design, there is no blocking concept. Randomized blocking is a blocking concept is involved. Okay. So because due to the not homogeneous, and we are uh, applying the treatments to individual units. Okay. Then I am studying the effect of the nitrogen, phosphorus, and calciums on these ones, and collecting the heats, and I am arranging. So treatment one, treatment two, so on via the treatment that are applied in the uh, first block, second block, third block, or B block. and what are the yields or responses that I'm collecting it. And now I want to analyze this one. Then you can go for the analysis of variance two-way classification. That means here for analyzing the experiment, we are using the statistical tool of analysis of variance, one-way classification or two-way classification. One-way classification if it is a completely randomized design. Two-way classification for a randomized block design. So completely randomized design is how the experiment you have to conduct the planning. That is most important. And once the experiment is conducted, we have to arrange the data in a one-way classification model and two-way classification model or three-way classification model. Then you have to carry out the analysis by using analysis of variance techniques. That you can understand what is the difference between one to the another at here. And the whatever the in the randomizer block design, we are testing the two hypotheses simultaneously because all treatments effects are same. All blocks effects are also same. That is nullified. So what you are going to test at here? Ith treatment effect is zero. Jth block effect is also zero. Alpha 1 equal to alpha 2 equal to so on alpha v, which is equal to 0. Beta 1, beta 2, so on beta b, which is equal to 0. Okay, so this. So for the randomizer block design, the statistical model is Yij is equal to mu plus alpha I plus beta j plus epsilon ij, and mu is the general mean and alpha is the effect of the ith treatment and beta j is the effect of the jth block and epsilon ij is a random error. Okay, now X is the design matrix. Then you can, if you are writing like this, then you can write the statistical model y is equal to x beta plus epsilon model, and you can carry out the analysis of variance of the two-way classification. The analysis of variance table will be like this. Okay, so just like sum of squares, that what you are calculating the analysis of variance due to treatment blocks and error and total and the degrees of freedoms that you are presenting at here, that the same thing that you can check it at here. um, Here, so block one, so six blocks and five treatments that are applied, and these are the observations. Now I calculated the totals and according to the two-way classification, and you can carry out the analysis, but I have not done the problem solvation at here. So this is that I will show the same problems in the by using the statistical tool in the tomorrow session, by using the design expert, and also by using the SPSS. The same problems of the RBD and LSGs also, that I will show it. And now the third basic design, which is the we are dividing the total experimental material into equi-sized. So similar type of the two-way classified data, like row wise and column wise, and the number of treatments must be same to equal. So here the treatments are applied row wise, column wise only once, such that no treatment is repeated. Such a design is generally said to be a lattice square. So each treatment is applied once only, one and one only, in each row and in each column. Such a design is generally said to be a lattice square design, and it is always a square type. So equal number of rows and equal number of columns and equal number of treatments. And in that case, we can go for the three-way classification model. So yijk is equal to mu plus alpha I plus beta j plus epsilon ijk. But here the randomization is restricted and local control principle is fully involved. But the repetition principle is also restricted. Even for the one-way restricted of the randomizer block design is nothing but a lattice square design. So there are some restrictions more of the randomization replication in lattice square design and also the other design. Okay, so So this is the part that what I'm stopping for today, and the analysis and this that implementation that I will give by using the software in the tomorrow session. Now, if you are having any of the questions on the conducting of the experiment or basic designs, you can ask now. You are welcome. Okay. You please unmute and ask the questions.
So this is the part that what I'm stopping for today, and the analysis and this that implementation
Good
that I will
afternoon,
give by
sir.
using the software
I'm Dr.
in the
Sunita,
tomorrow session.
currently working at
Now,
Geetham
if you are having any of
University.
the
It's a very
questions
nice
on
presentation,
the
sir. You have
conducting of the
taken through
experiment
all the basics
or
and
basic
explaining very
designs,
clearly.
you can
I have a question,
ask
sir.
now.
Can you please
Uh,
answer me this? Can you
yes.
please
You please
explain on the
unmute and
total variability,
ask the
sir?
questions.
Because you have said 2 points here, explained and unexplained.
Mhm.
So, can you please explain me what is total variability and how we need to know the explained or unexplained result, something like that you said there. You have taken through all the
So
basics
there is
and
total
explaining very clearly.
variation. We are
I
getting
have
the
a
some
question, sir.
variance.
Can you
That is
please
the
answer me
variation in
this?
the
Can you
observations.
please explain? Okay.
Why the
Total
variation that is
variability,
coming?
sir, because you
So
have
that
said
I'm
2 points
dividing the
here,
total variation
explained
into
and
two parts:
unexplained.
explained variation and
So,
unexplained variation.
can you
What is the
please
meaning of
explain
explained
me what is
variation?
total
Means
variability and how we need to
due to
know
some
the
reasons.
explained or
So
unexplained
the due to the
results, something
effects
like
of
that you said
particular
there. You
treatment
have
that is
taken through
applied,
all the
So
basics
there is
how much
total
variation that you are
variation.
getting.
We are getting the
So
some
this is called an
variance. That is
explained
the
variation.
variation, the observation.
So
So what is
I'm
the
applying
variation that is
nitrogen,
coming?
phosphorus, and
So
some
that
other.
I'm dividing the
So
total
due to
variation
these
into
applying
two
only
parts:
the
explained
variation that I'm
variation and
getting.
unexplained variation.
So that's
What is the
called it is
meaning
an
of
explained
explained
variation.
variation? Means
But unexplained
due to
variation,
some
I'm
reasons.
applying the nitrogen only.
So the
But
due to the
this is the
effects
truth.
of particular treatment that is
Same
applied,
size of
how much
stars,
variation that we are getting.
same type of
So
the
this is
heat
called an
or
explained
experimental
variation.
unit and similar
So I'm
conditions,
applying
same
nitrogen,
nitrogen,
phosphorus, and
but
some
I'm
other.
getting
So due
some
to these
variation is
applying
there in the
only the
observation.
variation that I'm getting.
That is called an
So that's called
unexplained
it is an
variation.
explained variation. But
Suppose
unexplained
patient
variation,
is same,
I'm applying the nitrogen
so he's
only.
not having
But
any
this
problem
is the truth.
of sugar or BP or
Same
any other.
size of
All the
stars,
patients are similar
same
type,
type of the
but
heat or
I'm
experimental unit
injecting a
and
drug of
similar
benzene.
conditions, same nitrogen,
So is
but
it
I'm
applicable
getting
to all?
some
May not
variation
be.
is there in the observation.
So
That is
even
called an
suppose if you are
unexplained
applying the,
variation.
if it is also
Suppose
applicable, then
patient
some
is
of the
same,
patients it will be
so he's
rapid
not having any problem
grasping is
of
there,
sugar
or
or
effect
BP
will
or
be
any
you
other.
can identify.
All the
In some
patients
of
are
them
similar
may not
type,
be that much of rapid.
but
So response may
I'm
be a
injecting a
different
drug
one.
of benzene.
So this is, it is depends
So is
upon
it
the
applicable to
uh,
all?
individual units.
Mm.
Therefore,
So
it
even
is
suppose
not
if you are applying
in
the,
our control. It
if
is
it is
totally
also
unexplained
applicable, then
variation.
some of the patients
Okay,
it will be
Okay.
rapid
but some type
grasping
of
is
the
there,
variation
or
which is
effect will
not in
be
our
you can
control,
identify. In some
and
of
we
them
cannot study it.
may not be that
That is
much of
called
rapid. So
unexplained
response may
variation.
be a different one.
Whatever the
So this
possibility
is it is
which
depends
we
upon
can
the
control, and by those
units.
that you are separating it.
Therefore,
That is called an
it is
explained
not
variation.
in our control. It is totally
I think
Okay, sir.
somewhat
unexplained
you can understand.
variation.
Yes, sir, I understand, sir.
Okay.
Sir, when you were telling this error determination under root s square by r, so s is the total number of observations only which we have to take, sir?
No,
Error.
SC square is mean square error. In
Okay.
the analysis of variance table,
Yes, sir, I got
corresponding
this.
to mean square column,
Right, I got it. Yes.
so that SE square, that SE
Yes,
square
sir, I
only that you have to
understand, sir.
use it.
Okay. Is there any limit or the range for this particular error determination and then value, sir? The total number of
Yeah, if
observations only
error
which
is
we have to take,
more,
sir?
then automatically the hypothesis will be rejected.
Rejected. Right.
Yeah.
Hmm.
So if error is
In the
less,
analysis of
then
variance table,
it will be
Yes,
accepted.
sir, I got this.
mean
Okay.
square column.
So
Right,
totally
sir. I
error
understand.
where that you are getting
So
only
that
in the
SE
responses or
square, SE
observations.
square only that you have to
Hmm.
use it.
So observations
Is
in
there
that
any limit or
explained
the range for
variation
this particular error
is
determination
more,
and then
unexplained
value,
variation
sir?
must be very less.
So if
Yes.
error is
Hmm.
more,
So if
then automatically the
unexplained
hypothesis will be
variation is
rejected.
more,
Rejected.
then the experiment is totally is
So if
wasted.
error is less,
Okay.
then
60% or 70% you are not in a position to explain.
so
Then what is the use
error where that you are
Okay.
getting
conducting of the
only the
experiment?
responses are
There is
Right.
no
observations.
use. That's
Mm.
why this
So
SE square
observations
must
that
be very
explained
smaller.
variation
Mm.
is
So
more,
unexplained variation
must
must
be
be
very less.
very small,
Yes. Okay.
and explained variation must be maximum.
Unexplained variation is
So
Okay.
more,
how much error that you are familiar? Suppose
Okay.
I'm allowing up to
60% or 70% you are
20%
not in a
variation
position to
only.
explain. Then what
Okay.
is the use?
So generally we are calculating the R square value,
Right.
coefficient of
That's why
discrimination.
this SE
Yeah.
square
So
must
that
be
generally you are
very
taking
smaller.
this part of the SE square
So
in that part.
unexplained
So
Okay.
variation
R
must be
square, whenever you are
very small.
calculating this R square
And
value,
explained variation
must
must be
be
maximum.
Greater
around
So
maximum of
how much error that you are
10% or
familiar? Suppose
20%.
I'm allowing up
Explained
to
variation must be
20%
more.
variation only.
Okay.
than. Yeah. Okay. Okay.
So that type of
Generally,
the
we are
precaution that you have
calculating
to
the
take it.
R square value,
Okay, sir. Right.
coefficient of discrimination. So that generally you are taking this
Any
part
more
of the SE
questions?
square in that part. So
Okay.
R square, whenever you are calculating this R square value, must
Ah,
be
sir, in the first example, when we
maximum
were
of
discussing regarding the T,
10%
all those things,
or 20%.
okay, you have
And
taken a
explained
very good
variation must
example
be
there, explaining in
more.
terms of T and discrimination.
So that
Now,
is the precaution that you have to
here I
take.
have a doubt, sir, actually, when we have given number of chances, okay, 0, 1, 2, 3, 4 we have given and we have drawn a table also, sir. So, uh, can you please repeat that, sir? Because number of wrongs, number of ways of chances, if you go to that particular table. Yes, sir. Very good example. Yeah. Explaining in the below one.
Yeah.
Yes.
Yeah.
Yeah. Now,
There are
here I
zero
have a
correct
doubt,
and
sir,
four
actually.
wrong.
When we have yes, sir, I understood that. Right.
So how
Okay.
many possible? Because totally,
0, 1, 2, 3,
first
4 we
method
have
four
given and
cups
we
are
have
there,
drawn a table also, sir.
and
So,
second cup four methods are there.
can you please
So
repeat that, sir?
zero
Because
correct
number of wrongs,
and
number
means
of
all are wrong.
ways of
So
chances, if you
four
go to
four
that
that I'm
particular
dividing
table.
it.
Yes, sir. Good example.
So
Okay.
four C zero
Yes.
means what is the value? One.
There are
Four
zero
C
correct
zero
and
value is
four wrong.
four
Yes, sir. I
C
understood
one.
that. Right.
I
So
think you
how many
know the
possible? Because
combinations,
totally
permutation combinations.
first
Four
method
C
four
zero
cups are
value.
there,
Okay, sir.
So
and
four C
second
zero
cup
is
four
nothing but
methods are
here,
there.
just like this. There are
So zero
uh,
correct
four possibilities are
means
there.
all are
Yeah.
wrong.
This
So
is a
four
sorry.
four that I'm dividing. So
Okay.
four C zero means what is the
This is
value? One.
first zero, second
Four
zero,
C zero
third
value
zero,
is
and
four
into mark.
C one. I
This
think
is
you
one
know
possibility.
the
Okay.
combinations,
So
permutation combinations.
second into mark,
Four C
second,
zero
third
value.
place that is got.
Okay, sir.
In second
Four
place
C
you
zero
got.
is nothing but
First
here,
place,
just like this.
first place that
There
you
are
got. These are the four different
four
possibilities.
possibilities are
This
there.
entire that you are indicating with
This is
four C one. That is four.
Okay.
And so the other
this is first
that you are four C
zero,
three
second zero,
zeros that I am
third
indicating.
zero, and
That
into
is
mark.
another four.
This is one possibility.
Okay.
So
That's why
second
4
into
into
mark,
4 that is
that is the
16.
third place that is
16.
got.
Okay.
Yeah.
Second place
So
you
there
got.
are 16
First place,
possibilities that are
first place
existing
you
like
got.
this.
These are the four different possibilities.
Hmm.
Because
This
G,
entire that we are
because
indicating with
the cups are different type.
one.
So there are different combination that you can select
And
it. Here
so
I'm
the
taking four
other
cups,
that you are
but
four C
out of the 8 cups you
zeros
are
that I am
selecting the
indicating,
four cups.
that is another four.
Hmm.
So which four that you are selecting?
Okay.
So that's why four into
There are
four
many
that is 16.
possibilities are there.
Yes.
Those
Yes.
all
Yeah.
counted in
So
this
there are
part.
16 possibilities
Okay.
that are existing like
Okay.
this.
Okay.
Similarly, at here
Because
also. So two
because
possibilities or three
cups are
possibilities
different,
correct. All correct.
so there are different
Okay.
combination that you can select
Okay.
it. Here I'm taking four cups,
Any
and
clarification that
out
you
of the
need
eight
more?
cups, you are selecting the four
Yes,
cups.
that
Because
is.
because of four
Which
cups are
four
there,
that you are
8 cups
selecting?
totally are there.
Yes, sir.
Which
There are
four
many
set
possibilities
that
are
you are
there.
selecting?
Yes.
Those
Yes.
all counted in
Yeah.
this part.
If these four are selected, then only that I have
Similarly,
written these are the four.
at here
But
also.
another four
So
sets that you
two
have selected,
possibilities or three
another four
possibilities correct,
possibilities.
all
Like
correct.
that, there are four
Okay.
different sets that are possible. That that's why
Any
I'm multiplying this
you
part.
need more?
Okay. Yes, sir.
Okay?
Okay,
Out of
sir.
four
Right.
cups are there, 8 cups totally are there.
Yes, sir.
Which
Any more?
four set that you are selecting?
Yes. Yeah.
If these four are selected, then only that I have written these are the
This
four.
type 1 and
But
type
another
2 two you have said, sir. It,
Yes.
yes, sir.
So the probability
Sir,
of
probability,
all
yes.
correct is point 0.014, which is less than
Right, sir.
5% error,
Yeah.
because I'm erroring only 5% type 1 error. So alpha is type 1 error. So probability of type 1 error is
You have
alpha.
said, sir. It,
So the
yes, sir.
probability is 0.014. There is
Sir,
nothing but
probability, yes.
1.4% error that is existing. This is also called p-value.
Yeah.
Okay,
Yeah.
p-value for the experiment.
Okay.
So okay, p-value is 0.01. So okay, because it is not 1%, not more than much 1%. So it is less than 5%. So 5% error is allowable.
Look.
Suppose in some cases, if you want to reduce this value, okay, then you repeat, instead of four 8 cups, take 10 cups. Then this value will be less than 1%. You will get 0.004 or 0.001, like that.
Yeah.
So if the
Look.
experiment is repeated, that means instead of 8 10 cups, or 11 cups or 12 cups, then it will be,
Even
this
less.
value will be very less.
Less.
Yes. So that's why. Because whenever you are taking the number of patients, if you are testing more, then accurate results that you can identify it.
Okay,
Okay.
okay. Right, sir. So tomorrow you'll be showing us the design of experiment with a
Implementation
which
by using
design
the
you are.
software.
Pardon, sir?
By using the design of experiment, the design expert, and by using software. So
Yes,
the
sir.
same
Yes.